This lesson is simplifying scientific notation in special cases. So here I have an example. One scientific notation subtract another scientific notation. As you can see, they are exactly the same thing. So on the left side is the same as the right side. So when you subtract and they are exactly the same, it's just 0. Again, why is this 0? Because the left and the right are exactly the same. So left subtract from the right and they are exactly the same. Same number, same power, so they go to 0. Okay, so the answer is 0. The second example, what happened if I change the number but the power is still the same? Here I have -2, here I have -2. The only thing I changed is the front number. So in this case, we only subtract the front, the first number. So 5.5 subtract 1.3, which I have here. The power, since they are the same, it stays exactly as is. So again, 5.5 subtract 1.3. The power, because they are the same, leave it alone. Okay, and then 5.5 subtract 1.3 gives me 4.2. Okay, so there's a difference between the same and this right here. I only changed this part. Okay, next example, what happened when the first number are different and the power are also different in subtracting? So in this case, we need to change the 5.5 into decimal. Since this is -2, start at the decimal because that's where it is. So -2 at the decimal, go 2 to the left because this is -2. So again, -2 from the decimal to the left. So 1, 2, so it is 0.055. Do the same thing on the right hand side. Change the 1.3 into standard form. And since this is positive, so go 3 to the right. So 1, 2, 3. And then after that is just basic order of operations. Subtract left to the right, and then you end up with -1299.945. Okay, so be very careful. This is a special case. When the left and the right are exactly the same, it's just equals 0. Now if the power are the same but the first number are different, you just subtract the first number. 5.5 subtract 1.3. What happened when the first number are different and the power are also different? So change it into standard form, change it into standard form and basic order of operations. Okay, so the first 3 examples are in subtractions. Now I'm going to use the same problem, but this time it's going to be in add. So again, the first 3 problem is subtract, exponent, scientific notations. So now let's do with adding. So here we go. As you can see, the left and the right are exactly the same thing. Same first number and same power. So we just add the first number only. So 5 plus 5.5 plus 5.5, that gives me 11. The power are exactly the same, leave it alone. Now we need to change this 11 into standard notation, which is scientific notation, which is from 1 to 9. So move the decimal. Since there's no decimal, start from the back and I move it over 1. And since I move 1, make sure I add this power 1. And since I haven't done anything to the -2, bring it along. And then 1 subtract 2 gives me -1. Okay, so again, this is also the answer, but it would be nice when you change this into a scientific notations, which is from 1 to 9. So this is also the same. So this answer and this answer are also the same answer. It's the same. The only difference is that this is 11. 11 is bigger than 9. and so we want this to be in scientific notation, which is from 1 to 9. Okay. Next example, same thing. When I have the power are exactly the same, the only difference is just the front number. So I just add the front number, 5.5 plus 1.3. The power are the same, so I leave it alone. So 5.5 plus 1.3 gives me 6.8. Okay, so that's for adding. Next example on adding scientific notations. As you can see, the first number are different. The power are also different. This is -2, this is 3. So first thing is to change this 5.5 into standard notations. So -2, move the decimal 2 to the left, which is 0.055, 0.055, and then this is +3, so move the decimal to the right, so 1, 2, 3 comes out to be 1300. And then that's just basic adding, so 1300 plus 0.055, which comes out to be this. And I want to change this into scientific notations. So here's my decimal, move 1, 2, 3. So that's where I got the +3 from. One more time, 1, 2, 3, and that's where the +3 comes from. Okay, so that is adding and subtracting scientific notations. So the first 3 is to subtract scientific notations, and then the next 3 is adding scientific notations. Okay, and then the next example, what happened if I have a power outside like this right here and it is -3? So I have a power out here and it is -3. So the first thing we need to do is change the inside into standard notations. So since this is -2, move the decimal to the left 2 times, so it comes out to be 0.055. Now we deal with the negative power. Based on the rule of negative power, I would take that power, bring it to the bottom, and then the negative go away. So as you can see, take this whole thing right here where I'm circling, put it in the bottom, and the negative go away. So I have 1 over this whole thing, and the negative go away. One more time, negative power, take this whole thing here, put it in the bottom, and the negative go away, and always 1 over it. Okay, and then after that, 0.055 to the 3rd power, you can use your calculator and just put it in the calculator. 0.055 to the 3rd power comes out to this entire number, which is 0.000166375 all over. Okay, so 1 over this number, and then use your calculator. 1 divided this number comes out to be 6010.5184. Okay, so this is just calculator to the 3rd power, divide also by calculator, and it comes out to be 6010.5184. You can change this into scientific notation right over here on the right hand side. So move the decimal 1, 2, 3, and that's where the +3 comes from. One more time, move this decimal 1, 2, 3, and that's where the +3 comes from. Okay, so be very careful what happened when I have an exponent that is negative outside. Okay, next example, so this example, when I have negative exponents outside, what happened when I have a positive exponent? So here's a positive exponent. Again, as you can see, I'm using the same scientific number value again, but this time it is not negative power outside, it is positive power. So option 1, you can write it out 4 times because this is 4. So this is 4, write it out 4 times. 1, 2, 3, 4. However, this is going to be a very lengthy process when you multiply. What happened if this number was 10? You're going to do 1, 2, 3, 4, all the way to 10. That's a very long process. It's a lengthy process. So but that's option 1. However, option 2, we're going to use power rules. So here we go. Based on the power rule, if I have multiple items inside the parentheses, I will distribute the power. So m to the a, m to the b. And that's what I have over here, a to the m, b to the m. So same thing here, follow the power rule. 4 distribute to 5.5, 4 distribute to this -2, which I have right here. And then use your calculator, 5.5 to the 4th power, which comes out to be 915.0625. And then multiply, because I have parentheses, so 4 times -2 gives me -8. Okay. Now I want to change this into better scientific notations, because 915 is bigger than the scientific notation from 1 to 9. So this is too big. So move this decimal 2 times. So 1, 2, and that's what I have here. So move the decimal 1, 2. So now I have 9.150625. And since I moved the decimal twice, make sure you include that. Again, where does this 2 come from? Because I moved the decimal 1, 2. Okay, and we are in power of exponents, so we can still add this. So 2 plus, okay, so 2 plus -6, 2 plus -8 will gives me -6. Or you can say 2 subtract 8 gives me -6. So there's 2 ways to say it. You can say 2 plus -8 gives me -6, or you can say 2 minus 8 gives me -6. Okay, so this would be the better answer. This is the answer as well. This right here is the answer, but we want to make it better because scientific is from 1 to 9. Okay. Next, I want to make a note of this. So note in scientific notation in a calculator. So in your calculator, if you use a calculator, sometimes you see this letter E. This letter E represents this 10 in scientific notations. Okay, so when we hand write scientific notations, we use the 10. But in your calculator, it will say E. Okay, so do not be confused. What is this letter E? So this letter E represents this 10 in scientific notations. Okay, so if I have 10 to the positive 6, your calculator might say E6. If I have -6, then it will say E-6. Okay, so one more time. If we handwritten out, then it will be 10-6. But in your calculator, it will use the letter E. So E is the same as 10. Okay, so here's an example. 5.5, 10 to the -6. Now, if you don't want to use this 10, you can change it to the letter E. This example and down here are exactly the same value. The only difference is that instead of using the number 10, we use the letter E. Okay, so again, the letter E is represent the 10. One more time. E is the same as 10. Just like the example that I have here. Instead of using the 10, I use the letter E. It is the same thing in your calculator. If you see this E, that is scientific notation. What is E? 10. Okay, so be very careful when you are dealing with special cases in scientific notations. So one more time, this is to subtract. Okay, this is to subtract. This over here is to add. What happens if I have a negative power outside? Okay, negative power outside. And what happens when I have positive power outside as well too? Okay, so be very careful. And then instead of writing the number 10, I can use the letter E. So your calculator, sometimes in your calculator, when you see the letter E, that represents 10 in scientific notations. Okay, so be very careful.